Welcome to RefineryPro, first episode. I'm your host, Manoj Kumar, and today we are diving deep into one of the most critical aspects of petroleum refinery operations, that is refractory materials. In this episode, we'll explore what refractories are, why they are essential, and how they protect our equipment in the harshest industrial environments. Whether you are an engineer, a maintenance supervisor, refractory inspector, or simply curious about refinery operations, this comprehensive guide will give you the knowledge you need. Let's get started. What is refractory? Refractory application involves the use of specialized materials to create protective linings in furnaces, kilns, and other high-temperature equipment. These linings do more than just protecting the surrounding structures. They maintain optimal operating conditions by withstanding extreme heat and chemical environments. Think of refractories as the guardians of your industrial equipment, standing between the intense heat inside and the vulnerable metal walls outside. Without these materials, our equipment would fail rapidly, and operations would become impossible. So, what exactly is a refractory? The word itself comes from the French term réfractaire, which means high melting. Refractories are specialized materials that can withstand extremely high temperatures and harsh environments without losing their strength or integrity. These materials don't just survive in extreme conditions, but they actually thrive. They're crucial in multiple industries: steel production, glass manufacturing, cement production, and of course, petroleum refineries. In each of these sectors, refractories play a vital role in enabling safe, efficient operations at temperatures that would destroy ordinary materials. Now, let's look at how refractories are officially defined. According to the Indian Standard 4041, a refractory is a non-metallic material, or a product containing some metal, whose chemical and physical properties allow it to be used in a high-temperature environment. More specifically, any material can be classified as a refractory material only if it is non-metallic in character and shows no sign of melting or softening when heated to a minimum temperature of 1500 degrees Celsius. And, internationally, the ASTM C71 standard provides a similar definition, that is, refractories are non-metallic materials with chemical and physical properties that make them applicable for structures or components of systems exposed to environments above 538 degrees Celsius. These standards ensure that the materials we use meet rigorous quality criteria and perform reliably in demanding applications. Now, let's understand why we use refractories. Refractory application is the process of installing heat-resistant materials to withstand extreme temperatures and chemical exposure. These materials act as a protective barrier, preventing heat loss and enhancing the efficiency of industrial processes. This efficiency gain translates directly into cost savings and improved productivity. In a process plant, refractories are applied for two primary purposes. First, conservation of heat. Refractories are excellent insulators, reducing heat loss through the equipment walls. This means less energy is required to maintain operating temperatures, resulting in significant operational cost reductions. And second, protection of the casing plate from corrosion and erosion. The harsh chemicals and abrasive materials inside high-temperature equipment can severely damage steel casing plates. Refractories create a protective shield, extending the lifespan of your equipment. To select the right refractory material and achieve the desired purpose, we must consider several critical factors. First, operating temperature. Different refractories have different temperature limits. You need to match the material to your specific temperature requirements. Second, the gaseous condition inside the furnace. The chemical composition of the gases, vapors, and fumes present in your equipment affects how the refractory will perform. Some materials resist certain chemical attacks better than others. Third, the type of operation. Are we running a continuous process, where equipment operates 24/7, or an intermittent process with regular start-stop cycles? Continuous operations create different stresses than intermittent operations. Considering all these factors ensures that you select a refractory material perfectly suited to your specific application. A good refractory material must meet several general requirements. Let me walk you through these. First, the ability to withstand high temperatures and trap heat within a limited area, like a furnace. This is the foundation of refractory performance. Second, the ability to withstand sudden changes in temperature. Equipment doesn't always heat and cool gradually. Sudden temperature swings create thermal stress, and a quality refractory must handle these fluctuations without cracking or spalling. Third, the ability to withstand load at service conditions. High temperatures can soften materials. A refractory must maintain its structural integrity and load-bearing capacity even at peak operating temperatures. Fourth, the ability to withstand chemical and abrasive action from materials such as liquid metal, liquid slag, and hot gases coming into contact with the refractory. This is critical in processes where your material isn't just exposed to heat, but to aggressive chemicals as well. Fifth, the ability to resist contamination of the material with which it comes into contact. We don't want the refractory to react with the substances it's protecting against. Sixth, the ability to maintain sufficient dimensional stability at high temperatures and after repeated thermal cycling. Materials expand and contract with temperature changes. Poor dimensional stability leads to gaps, cracks, and reduced effectiveness. Seventh, the ability to conserve heat, which we've already discussed. This maximizes efficiency. Eighth, the ability to withstand load and abrasive forces from equipment operation and material movement. And finally, a low coefficient of thermal expansion. This property minimizes the stress caused by thermal cycling, extending the life of your refractory lining. Let's break down the four basic functions that refractories perform. First, acting as a thermal barrier between a hot medium, such as flue gases, liquid metal, liquid slags, or molten salts, and the walls of the containing vessel. This barrier is absolutely essential. Without it, the metal walls would melt or weaken rapidly. Second, ensuring strong physical protection and preventing the erosion of walls by the circulating hot medium. Erosion is a silent killer in industrial equipment. Abrasive materials moving at high temperatures can wear away unprotected surfaces, but a quality refractory acts as a shield. Third, representing a chemical protective barrier against corrosion. Many high-temperature processes involve corrosive substances. Refractories resist this chemical attack, preserving the integrity of the underlying structure. And fourth, acting as thermal insulation, ensuring heat retention. By minimizing heat loss through the walls, refractories keep the heat where it needs to be, inside the process equipment, improving efficiency and reducing energy costs. These four functions work together to create a complete protection system for your high-temperature equipment. The performance and reliability of a refractory lining depend on three key elements that work in harmony. First, selection of the right material. There's no one-size-fits-all refractory. Your choice must be based on a thorough understanding of your operating conditions, temperature, chemical environment, thermal cycling frequency, and mechanical stresses. The right material selection is the foundation of success. Second, appropriate design. Even the best material won't perform well if the design is wrong. The thickness of the refractory lining, its layering structure, and how it's integrated into your equipment all matter. A well-engineered design maximizes performance and lifespan. And third, quality control during application. How well the refractory material is installed is critical. Poor installation, inadequate compaction, improper curing, gaps or voids can significantly reduce the effectiveness and lifespan of your refractory lining. When all three of these elements come together, the right material, the right design, and quality installation, you achieve maximum performance, extended equipment life, and optimal operational efficiency. Thank you for watching this comprehensive introduction to refractory materials. You now understand what refractories are, why they are essential in petroleum refineries and other industries, and what factors determine their performance. In our next episode, we'll dive deeper into the different types of refractory materials, their properties, and which ones are best suited for specific applications in refinery operations. Stay connected. The best is yet to come.